Hi, Assalamualaikum and good day. Today you are going to learn about the application of integration that is on areas. Following is the objective of today's lesson. Hopefully, by the end of this session, you should be able to evaluate the area under a curve and the area between curves using integration. The area under a curve between 2 points can be found by doing a definite integral between the given points. To find the area under the curve y equal to fx between x equal to a and x equal to b, integrate fx with respect to x between the limits of a and b. You may also be asked to find the area between the curve and the y-axis. To do this, integrate the function with respect to y between the bounded limit c, d. Next, we are going to find the area between the two curves. There are two cases that we are going to look at. The first case is we want to determine the area between y equal to fx and y equal to gx. Take a look at the following graph to get an idea on the area that we need to find. To find the area, first you need to find the intersection points between the two curves. The intersection points will be used as the interval of the integration. To find the area, basically you need to minus the area of the top function fx with the area of the bottom function gx. That is, integrate fx with respect to x minus integrate gx with respect to x over the interval. The second case is we want to determine the area between x equal to fy and x equal to gy. To find the area between the curve, you need to minus the area of the right function gy with the area of the left function fy. That is, integrate gy with respect to y minus integrate fy with respect to y over the interval. Refer to example 1. Find the area of the region that is bounded by y equal to x squared minus 2x and the line y equal to 0 from x equal to 0 to x equal to 2. Before solving, first, try to sketch the graph for a better view on the area of the region that you need to determine. Given that y equal to x squared minus 2x is a positive quadratic function, so it is represented by a U-shape with a small face. Before sketching the graph of this function, identify the x-intercept first. By letting x squared minus 2x equal to 0, solving for x, you will obtain x equal to 0 and x equal to 2. By sketching, you will obtain the following graph. Take note that y equal to 0 refers to the x-axis. Thus, the area that you need to find refers to the following shaded region, which lies below the x-axis. Here, the top function is y equal to 0 and the bottom function is y equal to x squared minus 2x. Thus, the area of the shaded region is obtained by solving the integral of the top function minus the bottom function over the interval 0, 2. That is, by solving the integral of negative x squared plus 2x with respect to x from 0 to 2, you will obtain 4 over 3 unit square as the final answer. Now, refer to example 2. Find the area of the shaded region that is bounded by y equal to x squared and y equal to x plus 6 from x equal to 0 to x equal to 2. Given that y equal to x squared is a positive quadratic function, so it is represented by a small face with vertex at the origin. Meanwhile, y equal to x plus 6 is a linear function which is represented by a straight line from the top right to the bottom left. Sketching the graph, you will obtain the graph as follows. As the interval is from 0 to 2, the area that you need to find refers to the following shaded region. Here, the top function is y equal to x plus 6, and the bottom function is y equal to x squared. Minus these two functions and simplify, you will obtain negative x squared plus x plus 6. Integrate with respect to x over the interval 0, 2 and simplify, you will obtain 34 over 3 unit square as the final answer. Refer to example 3. Find the area of the region that is bounded by y equal to x squared plus 1 and y equal to x plus 3. Given that y equal to x squared plus 1 and y equal to x plus 3 are quadratic function and linear function respectively, which are represented by the following graph. By letting y equal to 0 for both function and solve for the x, you will obtain two intersection points at point x equal to negative 1 and x equal to 2. Thus, the area that you need to find is shown by the following shaded region. Here, the top function is y equal to x plus 3 and the bottom function is y equal to x squared plus 1. Minus these two functions and simplify, you will obtain negative x squared plus x plus 2. Integrate with respect to x over the interval negative 1, 2, you will obtain 9 over 2 unit square as the final answer. Proceed with example 4. Find the area of the region that is bounded by y equal to square root x, y equal to x minus 2, and the x-axis. Given that y equal to square root x, y equal to x minus 2, and y equal to 0, which refers to the x-axis, are represented by the following graph. By letting y equal to 0 for both functions and solve for the x, you will obtain two intersections at point x equal to 1 and x equal to 4. Y equal to x minus 2 intersect at x-axis at point x equal to 2. Thus, the area that you need to find is shown by the following shaded region. As the shaded region is bounded by three functions, it will be easier to solve the area using the integration with respect to y, or in the short form dy. When using dy, you need to minus the right function with the left function, which are both in terms of y. Here, the right function is y equal to x minus 2, which can be written as x equal to y plus 2. The left function is y equal to square root x, which can be represented as x equal to y squared. Minus these two functions and simplify, you will obtain y plus 2 minus y squared. Then, determine the interval for the integral in y value. Here, the interval started at point y equal to 0 and ended at y equal to 2. Thus, integrate with respect to y over the interval 0, 2, you will obtain 10 over 3 unit square as the final answer. Refer to example 5. Find the area of the shaded region. As the area are determined by three functions, it will be easier to split the area into two shaded regions denoted by A1 and A2. For A1, the top function is y equal to x plus 6 and the bottom function is y equal to negative 1 over 2x. Minus these two functions and simplify, you will obtain 3 over 2x plus 6. Integrate with respect to x over the interval -4, 0. You will obtain 12 unit square as the answer for A1. As for A2, the top function is y equal to x plus 6 and the bottom function is y equal to x to the power of 3. Minus these two functions and simplify, you will obtain x plus 6 minus x to the power of 3. Integrate with respect to x over the interval 0, 2, you will obtain 10 unit square as the answer for A2. Plus the two answers A1 and A2, you will get 22 unit square as the answer for the area of the shaded region. In order to check your understanding on today's lesson, please do the following exercise. In the next lesson, you are going to learn on how to solve the volume of solid of revolution using integration. So